Thank you for organizing this, which is really important. This entire kickoff meeting is really important for us to sort of get to par where we look, in the way we look and we perceive the practice of citizen science. I've encountered it under the University of Haifa with Professor Dori Edelist, who is not with us, unfortunately today. When we started looking at jellyfish at sea, and jellyfish are a pretty unique and classic fit for citizen science, and I will elaborate on why and sort of try and take it from jellyfish to the wider usage of citizen science. And we'll also look within Iliad, the project that Valentine mentioned before. We are also looking at citizen science catalogs in one of the work packages, and I will tell you some initial and very interesting lessons that we have from there. So without further ado, we'll jump right in. So why jellyfish? First of all, for winning hearts and minds, jellyfish are surprisingly good candidates, because most people will just say, oh, I hate jellyfish. But as you'll see in the bottom line of this slide, eventually hate and love can coexist. And this is something that creates fascination within people. They're ancient animals. They're the sponge people and the jellyfish people are always arguing about which animal is the oldest. So they're one of the oldest animals. They're beautiful, they're mysterious and captivating, often invasive because they are planktonic and drift with currents, and also can be easily transported by vessels as hull fouling or in ballast water. So when they do invade, they're often invasive because gelatinous zooplankton and plankton in general is something that is at the very base of the food web, potentially dangerous and certainly harmful, but also beneficial because there's a lot of good things that we can make from jellyfish for human benefit. They are common. They're one of the most common animals out there. Anyone who goes in the water in Israel for sure is going to be to become familiarized with jellyfish, especially in the bathing season, because they tend to bloom at the springtime and sometimes summer, which is when people get in the water or go to the beach. And mostly jellyfish are a fit because there is a real world necessity. This is not some idea that was born in the mind of scientists. This came from the public. The outcry for, hey, we want to know when and where the jellyfish are so we don't get stung. And following that, the public, when it becomes interested and you provide them with information about jellyfish, they also want to know more. And they want to be part of documenting their presence, and it's exciting for them. They feel like they are ambassadors of in their communities when they are able to alert anyone to the presence of jellyfish, especially during the bathing season, and especially the stinging species. But also when they get in the actual process of reporting and learning about them, also the other species, and also in other seasons. So why are jellyfish, even if they're not stinging, so interesting? Here is a great GIF of one species of comb jelly eating another. These are non-stinging species who have decimated the Black Sea small pelagic anchovy stocks in the early 1980s and 1990s. And one species arrived and decimated the stock, and another species, the one devouring it, actually invaded right after it and sort of in biological warfare regulated its population. So you see, jellyfish can be fun and interesting and captivating, dangerous, and all of this and the stories behind them make them a perfect fit for citizen science. And other animals, you know, that are especially prevalent in citizen science initiatives and projects like marine mammals and sharks, they share some of these properties with jellyfish. And once again, when the public wants to know about something and the public feels that there's a need to learn, then it's a real place to address the public. Now, we've worked with people from kindergarten to elderly people, and also with a lot of dedicated groups such as lifeguards and kayakers, divers, swimmers, and yacht people. And really, this is a cross-border and cross-discipline issue, jellyfish are, that is captivating for everyone. But I would like to tell you, for the hearts and minds story about one school in a city called Naharia that we've worked with. And this is the wrong school in the wrong part of town for us, because Naharia is a coastal city, but there's a highway dividing the city. And this school is an Orthodox school where not the teachers nor the kids ever got to the beach during school, for sure. And also in their spare time, there was only this one kid out of 60 people, out of 60 kids in the fourth and fifth graders. Only one kid was saying, yeah, my dad is a surfer and we go to the beach a lot. But all of the other ones did not go to the beach a lot. Really, they were from the terrestrial part of town and had no interest in the sea whatsoever. And we got them within a year of bi-monthly visits to the school, and by educating the teachers and getting the teachers involved as well. Like one of the teachers was saying, I hate the sea and I hate the beach. The sand gets in my feet. And all of the kids and all of the teachers had an amazing transformation that year, because not only did we teach them a lot about the sea through jellyfish, and I'll let you know in a minute why jellyfish are also connected to the environment, but also it sparked their interest. And we had a weekly session of them in Zoom, just shooting questions at us. And it was, it always ended as being more time than we had decided to devote to this, because they were really into it. And we got them to university to see what university is like, what higher education looks like through citizen science. We took them to the beach, and that has an amazing transformation, because through jellyfish, which doesn't seem like the classic animal to study about the marine environment from. People usually start from other things, but we got them to think about the environment, because if we toss a lot of plastic bags out there, sea turtles will think that they're jellyfish and eat them. And also the jellyfish have some of them, the scyphozoans, they have a metagenic life cycle, which means that they have a polyp stage that sits on solid items or rocks originally on the bottom of the sea and spreads there. And this benthic life cycle, the polyp stage, it could sit, and usually does sit, on solid items such as plastic that have no previous algae or sponges or something, or corals that bothers with the settlement. So if we fill the ocean up with plastics and with litter, and we build too much in the ocean, then we do risk having more settlement places for jellyfish polyps. So we could also speak about the environment. And these kids who almost never visited the beach became social leaders in their communities. They dragged their parents in there. They brought the like what I showed you before. This panel is part of the every class had a poster designed according to what they learned, and this is part of it. There were like 3 panels like this, and this is like end of the year show for them. And we tried to get them involved with citizen science by adopting the Naharia beaches, and we wanted them to get there a lot and to report a lot of jellyfish from there on a weekly basis. And we couldn't get that done because they were just kids and had to be driven there or taken there. And scientifically speaking, this was a disaster, because they were pressing send 50 times on the smartphone, and or going back home to their computer and just typing a lot of random stuff. And they weren't our gold users that we imagined that they would evolve to be, but they were really, really into it. And by lobbying for actually getting to the sea, they managed to convince the city of Nahariya to sponsor both sailing classes, seamanship, kayaking. They tossed them in the water with life jackets. Kids who have never been in the sea, never been in the water before, they made like a big circle with life jackets a couple of times in the beginning of classes, and it was and also the teachers. So we got a whole community that was not a beach going, not your classic beach community. We got it involved in marine issues just through jellyfish. So that was for us a huge success story, socially speaking, even if not scientifically. So that was one aspect, and the other aspect I would like to speak about is jellyfish monitoring or jellyfish citizen science observation network that we have created. Us in the University of Haifa, we've been working with jellyfish for about 11 years, and when we started the Iliad project, we've discovered that there's a lot of others like us. We sort of knew that some of them existed, but for the first time, we wanted to sort of catalog them and get them all together to meet and discuss. And the reasons for creating such a network, and this network today is about 14 different initiatives across Southern European seas. We worked from Portugal to Turkey, and the reason for creating the network are the sense of a shared mission and faith and challenges. It gave us a chance to share our experience, liaise, and celebrate, and also celebrate our achievements, and also mourn the loss of people from our small jellyfish community that we lost, because one of the leading scientists in the field of citizen science is not, so unfortunately, no longer with us since 2021, and this was a very strong binding force for most of the people to meet and look at the competition and see how we can turn them into allies, and sort of not work against them, but work with them on common problems, pool the resources together, because poor resources are the main thing that hinders most of the citizen science projects that we've spoken with. Share data. Some of the data was shared by some of the initiatives, and until we got to the point of looking at data ownership, and then we sort of stopped in our tracks and said, okay, we're not just taking your data and we want to use it to create some products that are will serve us. We want to share with you also the discussion about how the data can be shared, standardized, harmonized, and look for really the common grounds. When you want to take projects from the local to the regional, and maybe even to the global, it's really, really important that you create a network of all the people involved. So you, A, don't have, you don't make enemies out of people that feel like you're encroaching on their territory. B, you actually turn them into allies that help you with doing that, which is what networking is all about. We want to get a joint publication out, and we started working on it that describes the activity. Look at novel technologies such as AI for image recognition and of jellyfish, and really until space, will enable us, like a technology, or through space, or underwater drones, or gliders, or cameras, something mechanical that can replace the human eye can do this. Then for jellyfish swarm observations, for sure, the lone jellyfish, but even for swarms, technology is not there yet. Until that happens, it's us, it's humans, and we do a pretty good job of describing jellyfish swarms through citizen science. So we got feedback for collection methods and standardization of the data, and this is something that in OTTERS we would like to work on further and expand and really get this right. This does not mean that all 14 initiatives in the network will be working in the same way. And also they highlighted the importance of stuff like language and local customs and local connection of the scientists with the people, which is a really important thing that machines will I don't know if they'll do it that well. With AI nowadays, you never know. But the personal connection with the citizens is is a really big part of what keeps them going, answering their questions and catering to their needs. So this standardization and automatization and the maybe even globalization of citizen science that we are putting on the table here does not mean that it has to entail the loss of the personal relationship, which is all too important. We got good feedback, and we hope within OTTERS to be able to capitalize on it and strive towards that harmonization and standardization. I'll show you a bit about what the data looks like in a minute. These are the main initiatives that we've contacted. They are spatially distributed across the Mediterranean the Northern Mediterranean and Southern European seas, which we focused on. There are, of course, many other initiatives that are not mapped here, some even local within the Mediterranean, that some of them are not exactly active, some of them are just small, some of them are, so these are the main ones that we mapped. There are also global initiatives that map jellyfish within the Mediterranean and Southern European seas and the Black Sea, such as jellywatch.org or iNaturalist, which is really becoming a major global repository and citizen science website that many people use. And there is overlap, of course, but creation of this network also gives us some kind of a bargaining position when we address these global initiatives, because if one of them becomes really strong and really good and something that we want to capitalize on, well, then we may work together in that sense to achieve the aforementioned standardization and harmonization, which is important for science, for the citizens as a feedback loop. It's also important because we will be able to give a better service. Now, in order to do this, one needs to first of all understand the species that are present in the basin, and we've been able to do that from the information from the different initiatives. We call them JOIs, Jellyfish Observation Initiatives. So the different JOIs provided us with data and also with metadata. One way that we suggested to, in order to harmonize at least the way that the data is, part of it is data collection, and the other part is what to do with the data when you already have it, and the way to store it and the way to make it interoperable. We proposed, and also listening to the JOIs and what they said, we proposed the Darwin Core, which is a standard for biodiversity observations. And of course, there are many types of citizen science projects, marine citizen science projects out there, and jellyfish is of course just one of them. But most marine citizen science projects are still about collecting biodiversity data. A little more than half, I think, in general. So the Darwin Core is a good way to start. It's not an end result by any means. It's just storing the data. There is still the analysis part, and still what you do with the data, how you map it, and how you translate this into actionable items that can be viewed by the public as beneficial, and thus keep interest of the people in the project and ensure long-term capacity, which is critical for citizen science project, because we have, when we view the catalog later, you will see that many projects end after 2-3 years, or really don't get off the ground. And in citizen science, in most citizen science, unless you have one specific objective that you need to complete, and then you say, okay, I'm done with it. If you want an ongoing project, you must have long-term participation from the citizens, and this is by no means an easy task to achieve. And contact with them, as I mentioned, is key to this. Sort of them feeling that they're not just working in front of a machine, but that there's people on the other side that take care of the data and return it to them in a way that they can consider actionable. So this is one way is to collect the data and store it in a Darwin Core standard. This could be stored in OBIS or GBIF, one of the larger data repositories such as Pangea, and etc. And in order to achieve that, and once you achieve that, then comparability across different regions and across different initiatives becomes feasible. And then you can actually say something about your area of the ocean and what's going on in there. This really was a good chance to meet everyone. This was fun, creating a network. Part of it is actually creating the connections between people, because most of the people there have not met each other, for sure not together before this meeting, but sort of knew that something was going on, even in the same region, because there was some overlap. It was fun to get everyone together. It was really a feel-good meeting. And okay, and this is what the metadata that we got looks like. We have different initiatives, and we know the where and the what and the how much. And the how much, for example, if you look at the fourth row, the abundance, then it's either abundance of jellyfish or density of jellyfish, and this encapsulates the very the most challenging thing about harmonizing data is when you have different data collection methodologies that have not been standardized yet, because this is just what everyone came up with, and there is either density or abundance or both, and density could be for a square meter or for a cubic meter. And for counting jellyfish, this is of course only what you saw, and this has to be calibrated by the time you spent in the water or the distance that you covered. And so what we decided to do was take the lowest common denominator here, for example, which is just description of either a situation of no jellyfish in the water, few jellyfish in the water, or a swarm of jellyfish, and sort of get all of them under the same lowest common denominator. Under Darwin Core, this does not mean that the specific data collected is not to be kept. We keep all the data, of course, and in the analysis phase, we hope to categorize it in a way that that enables us to look at different methods of data collection and show what is best for standardization. So this is general data. You can have metadata about the language, the motivation, which could be commercial or academic, years of activity, and once again, we only focused on the active initiatives, social media that most of the websites run, and many other aspects. Of course, species, as we said, are an issue of concern because you get different species in different places. And altogether, there are some successes from creating the network that we can already report and hope that we will capitalize on them, which is the data that was shared. Some of them really sent us even not only the metadata, but actually the data itself. As I mentioned, data ownership was an issue that is still to be handled. We made connections, we got to points of agreements and disagreements, and understood what these mean for the future, let's say, sustainability of the practice. And we looked at challenges. There was data that was not shared due to the data ownership. And when I say ownership, it's not just the people who run the academics usually that run the operation. It's also concern about the citizens who reported it and did not consent to like third-party data transfers as we suggested. Funding was the main issue raised. It's really hard, and it's a lot of hard work. Francesca from EXA, I think in the first lecture said that it is not for free. It is not a free thing. So it's not a freebie that we get from people that they report. This costs their time and our time, and funding is always an issue for these projects. They run on soft money from 2 to 3 year grants like we do, mostly from the EU, but others as well. Some of them have managed to secure local funding from municipalities, and really looking at what the clients are of citizen science. Who is your stakeholder that you need to engage is really important if you want to be able to support the project for a long term. Data validation, always an issue in citizen science. Very time demanding, can be done by machine learning if photos are obligatory, and also can be done by citizens, actually by trained citizens. So far, none of our initiatives has used citizens to tag and annotate jellyfish observations, which is a shame, I think, because this could potentially also help, not only help with validation, but empower people. We do have gold users in, I think, 4 of the 11 main initiatives. There are gold users who are given extra weight and extra credit when reporting jellyfish. Data, the way it's kept and managed, so far as the little data that we got, is not always according to fair principles. And there were also concerns raised about forecasting. For example, if you forecast a jellyfish swarm in a given beach, then tourists might not go there and hurt the local economy. But this is, I think, something that can be overcome by giving a better service of forecasting. And also, many times people get to the beach and just don't go in the water, which is probably the right thing to do, or just protect themselves when they go in the water, which is part of what the websites teach people how to do, as not only what to do if you get stung, but also how not to get stung in the first place and how to protect yourself. So in general, this was for us a very interesting experience creating this network. We feel we've benefited from that. I think we're short on time, so I will wrap up by presenting the citizen science catalog that we've started looking at in ILIAD, in task 3.4, deliverable 3.4. We took several other repositories. You can see them here, such as the US government one, and really we focused on Europe and European waters. So we sort of filtered out the US government ones that weren't international or included European waters. Took EU citizen science that was shown before, the Zooniverse repository, SciStarter, and SciSkyX. There's 2 SciSky websites, one American, SciSky.org, and mine, SciSkyX, which is European. And we filtered these for marine projects that are active and that are in and around Europe. And we looked at the overlap. And the overlap was surprisingly low. There were very little examples of projects appearing surprisingly, shockingly, in more than one repository. All the white ones that you see, and many more white ones in the in this database are only appearing in one project. And this is because of several reasons. First of all, several projects that are tagged as active are no longer active. Second, the way that the data was collected in each one of these catalogs was slightly different. Some of them used also included freshwaters, others didn't. Some of these also included the projects that were completed and still considered active. Some didn't. Some of them, I guess, just the way they went about the business of cataloging was different. So this begs the question: does a catalog of catalogs become something that is really, really needed here? I think yes, and this is something that we can work on within because we don't want to just create another one of those. And the second question that I think becomes very, very important is whether we can have some way of technology bridging these problems by looking at which projects are active, or something that will look at these repositories and fish from them just the active projects in a way that will make the database not only inclusive, in order to, for example, if I wanted to look at these databases and sort of create a network like we did with the jellyfish, then many projects will not appear in here. Our jellyfish projects, for example, there's only 2 or 3 of these 14 that appear in these data sets. And sometimes it's language, sometimes it's just that the search for projects within these catalogs was not extensive enough. And so the question of having it not only extensive enough and inclusive enough, but also something that is updating in a way through maybe through data scraping or some other technology is, I think, key to what we do in OTTERS now. Since I'm not a tech person, I will leave this for people that are more adept at this than myself to lead. But we are certainly willing to contribute from what we've done within ILIAD, and also we need to decide the standardization of the catalog, which means which fields we want to collect. All of these initiatives, catalogs that I've shown before, have different fields that they collect. So right now within our ILIAD catalog, for example, these are the fields that we focused on. And of course, there has to be a field of whether the initiative is active or not. We just focused on the active ones. We have 110 currently covered in there. We could probably have much more if we do dedicated searches, for example, for marine mammals or sharks, or even sponges and less interesting groups. But what we saw that when we did a dedicated search for jellyfish, we came up with many initiatives that were not there in the initial catalogs. So these are things to think about when we come up with the catalogs. And also it has to be cool. It has to be designed in a way that is appealing, and we think there are already catalogs out there that did a pretty good job of that, and also of even collecting all of the metadata in a proper way, like the US example. US government example is good with that. The EUCS example is very good with what it looks like and feels like. Sky as well. And there's a bit something small to be learned from any one of those. And with that, I will open the floor for questions. Thank you for being with me.